So I think what we will do is to jump in. So one of the things that we had wanted to do was to show you just how you can generate the plots that MTS already talked about. So the future time series plot is one of the graphics that you can use to see the variability from the different scenarios and from the different models. So this is what MTS just described. The thickness of the line here, the line represents the multi-model, the multi-GCM average. It's a time series from 1950 up to 2100. And the shading represents the variability amongst the different models. And you can select a bunch of different variables here. You can select the season. So you can also select winter, spring, summer, fall. And you can also put both RCP 4.5 and 8.5 on this. And so again, I'm just looking at it from Moscow, but we could also change it. I'll do that in the next example. So this is how we can generate the same plot that MTS looked at. And again, this is heavily smoothed. So the actual values for summertime maximum temperature would be, there would be a lot of annual variability up and down about these averages. But these have been smoothed so that you can see what the trend is. If we just put the annual variability, it would be a big spaghetti mess here, and it would be hard to see that trend. So you can see here that the red represents the trend in the RCP 4.5, the higher emission, the blue is the lower. And you can see how they deviate. They start deviating for temperature. About mid-century, they're really starting to deviate there. So the difference becomes more apparent after mid-century. Another thing to notice here is that there is a lot of variability in the models, even for the historical period. So even though we do a statistical downscaling, which where we try to correct the statistics of the historical period, not all of that, we do that at the daily scale. And so when we start reporting things at the monthly, seasonal, annual, there's still potentially can be a lot of variability in the models about the average. So that's the reason why there's a thickness here. There's still model variability even for the historical period. The average is going to align pretty much with GridNet, which is our historical training data set for the downscaling. I didn't mention that before. So the average here is going to pretty much align with averages, or at least the average of the average over this time period is going to align with GridNet. Yep, so then I also wanted to go in.
Catherine,
and,
could you enlarge your size of the thing if you can?
Try to zoom, you mean to maybe to this, maybe?
Oh, this is good. Yeah. Or I thought we want to maximize the window size. This is good.
Oh, okay. Okay. So then for the scenario studies that MTS was talking about, we can look at some of the variability amongst the models and scenarios and such. For the scenario planning, we can look at the future climate scatter tool, which will give you a scatter plot of different variables, where you can choose what to put on your y-axis and on your x-axis. And I think MTS put annual, so we can choose. Again, we can choose a location. And so I'm going to go through actually a quick little thing where we can change to a rectangular area, just so you can see how this location setter goes. So rectangular area, it opens up this little pop-up, and we can actually set the corners of the rectangular box. We can give our rectangle a name, and we also can like move a rectangle or resize it directly on a map. So for example, MTS was using Southwest Colorado. And so here's Colorado there. And we can actually resize it, and we can refine it by entering coordinates here. We can also give it a name, Southwest Colorado. Anyway, so that is so then we return to the tool. It's actually, the data is actually for Southwest Colorado, and you can see here it's using the RCP 4.5. So we can put temperature on the y-axis, and we can put a lot of times when you're doing scenario studies or scenario planning like this, there's a certain kind of metrics that are really important for either your species or the certain thing that you're modeling. So here I'm just going to repeat what MTS did, which was to look at annual mean temperature on the y-axis and annual precipitation on the x-axis. And I think it was percent change that we did on the y-axis. So here we can see we've got the yellow represents the early century projections with respect to the historical. So that's the little cloud of GCMs. And if you hover over the different GCMs, it'll actually tell you. So GFDL ESM 2M is one of the global climate models, and it'll tell you which model it is when you hover over it like this. But you can see that if you hover over the yellow, you can see the little cloud of projections for the early part of the century. For the 2040, this is the mid part of the century is the pink, and that cloud starts to disperse out. And by the end of the century, sorry, the purple, you've got projections all over the place. So you've got, and these different models here represent the space of projections for annual precipitation and annual temperature that are from these different 20 different models. And when you do the scenario planning, you kind of look at a driest warm model, which is what this might be. It's the lowest percent change in precipitation. And it's a pretty high change in temperature. So that might be a warm dry model. And then you've got some others over here, and you can actually hover over to identify. So you can see here that the CAN ESM 2 for the for the end of the century kind of defines your space. And then you also can get the means. So this will highlight, if you hover over these, it'll actually highlight where your mean is. A lot of times in scenario planning, you do use the mean as well as one of your models. And so you can see what that actual projection is for the different time periods. So for the mid-century, we've got a mean here of 3.3% change in precipitation and 6.1 change in temperature. And if we look at the little cloud for the pink dots, we might see this model. The IPSL is a dry, maybe warmer dry model. This is maybe a wetter, colder, cooler model, and the GFDL ESM. So this tool can be used to identify the models that kind of like are extremes in your space. They can be identified to see what the projection is for the mean. And then it can be a start for your scenario planning, because then you can take that model like the CANS ESM and you can explore what kind of impacts you might see with the CANS ESM 2 to see what impacts there might be under a very extreme wet warm situation. Okay, so then what can you do with that model in the toolbox? So let's for CANS and then also for the IPSL. So if you go back to the Climate Toolbox, we have our multi-purpose mapping ClimateMapper, and in here under time scale, you can look at past, forecasts or future. I'm going to pick future, and we can look at climate. So there's some different things to choose here, but we're just going to look at climate, and we can look at mean temperature and winter mean temperature. Maybe that's fine. Maybe winter precipitation, and we have the other seasons here, and we can look at maps and actually zoom into an area and see like around whatever area you're located in. Oh, so I'm sorry, you guys are in the North Central. So we can look at Colorado and kind of zoom in to see what kind of different projections there are for Colorado. So you can see the spatial variability of your projections here. Let's see. Okay. So here we've got winter precipitation, and right now we're looking at Colorado, and we're just seeing that, like this area here, the Rockies has higher precipitation and winter precipitation than other regions of the Front Range and other areas of Colorado. But then you can also, that's the historical, and then you can also look at futures under maps of projections of that same winter precipitation. If you look at the mid-century to see how that changes. Oh, that's great. I know that's happening because my point is out there. Okay. And then if you click on the map, you can actually get the value too for that location. Right now, the default is just to show you the model from the 20 downscaled, the mean from the 20 downscaled model, but we can actually use here the model that we got from the scatter plot, and we can look at what a future would look like under that warmer, wetter model from the scenario planning. And a lot of these potentially could look very similar. This is the future under the 4585. We can also look at differences. So this would be a very extreme precipitation situation here. Perhaps we should look at temperature. But the point was for this that you can use the models that you get from the future scatter plot, and you can go and find those models in these other tools to see how those different extreme models, what kind of impacts those models might predict. And then also, like in this tool here, you can download, you can see that spatial variability in the different projections. And then you can also download that raster data. So we have some download data, download map. The download data, you can download the raster data in either GeoTIFF format or in netcdf format. So you can actually download the map layer and actually get that on your computer and do your own analysis with this gridded data in this area of interest for that model that you got from the scenario planning. Additionally, another tool that you can look at is the future Boxplots tool, which is here. And this one gives you kind of like a more location specific, it gives you for the different models and for the scenarios. So for example, here we've got the same kind of options. You can look at, summertime, maximum temperature. You can look at RCP 4.5 or 8.5. And you can see the little dots represent the different models. And so you can see the spread of the different models here in a certain projection. And we've got the historical period for here we've got Moscow, Idaho under that RCP 4.5 summertime maximum temperatures. Here's our historical period. Here's our early, mid, and late century. The line represents the mean from those 20 different models. And then you can also see in these box plots really clearly like the range of uncertainty in that projection due to the different models. And then if you could combine the two results, you could also see very clearly here the range in projections if you looked at RCP 4.5 instead, and how that plays a role in the projection for your different time period. In each of these tools, you can also download the data just like we just did. So you can actually download the data. You can download the graph and actually get this graph on your computer as a PNG or graph format, but then you can also download the data and you can get those actual numbers straight here and see, like for that CAN ESM2 that came from my scenario planning, it was my warmer, wetter model. I've actually got now what the CAN ESM historical was. I don't know if you can see this very clearly or not. But I've got the historical value of 79.43 for the minimum temperatures. And I also have some future values for the early, mid, and late century. So this is a way for you to get that data on your computer, and then you can actually do some analysis of your own on your computer or use those values. So you don't have to just pick them off the graph by hovering. You can download them. And then lastly, sometimes the Climate Toolbox, the future data is all daily data. And I realize we just have 5 minutes left, so I'm going to say this in like 2 minutes. What I'm going to say here, we have daily future projections for the 21st century. But the Climate Toolbox, most of what you've seen, what I've showed you, have either been monthly summaries or seasonal summaries or annual summaries. But it may be that the thing that you're concerned with is not monthly or it's not annual. It might be more fine-grained than that. And you might have a different kind of question where you don't want temperature, but you want something that can be easily be derived from temperature. And so there's a tool here. It's the data download tool. And you can also get it from the regular thing. It's the very last tool here where you can download data, daily data, and do your own analysis, and it'll download into an Excel compatible format. So I've got Moscow, I've got a point location. I can get the future climate data here. And my example is just quickly, Spokane, Washington has a Bloomsday run every year that they do at the beginning of May. It's the first week in May, and the group that in Spokane that we worked with wanted to see how those projections for maximum temperatures on that day of the run might change, because in the last 10 years, the Bloomsday run, there's been a lot of heat stress in those and on those the day of the run, the actual Bloomsday run. So I can use this tool to get data from like RCP 8.5, and I can return only the days, like say from May 1st to May 7th. So that would be like the first week in May. And then I can even refine it more, and I might not be interested in everything here, but maybe I'm interested in the early part of the century, 2030 to 2059. This is something that all of our graphs don't provide 2030 to 59. We go 2040 to 69. So this is a way for you to tailor the data that you have. And then you can get the maximum temperature, and you can get some models from the scenario planning. We had the CANs, we had a GFDL, and maybe one other model. And then I just click download, and I can get that data in an Excel ready format where I can start analyzing it and calculate my own means and my own change. So I can download the future data here, and I can also download the historical data. Yeah, and I think we've kind of run out of time. I'm hoping it's just going to pop up in a second here. But maybe I will give it back to Matthias to say a couple more words. This should open up in Excel once it's ready. But yeah.
That's always the danger with live presentation.
Yeah, it is, but you know, it will come, and then it will just all of a sudden come up. So go ahead.
I must say that Climate Toolbox really kind of gets you the data in time. And so it really is very fast relative to other tools I've used. Yeah, if there are any last couple questions or comments we can take at this point would be great. If you have any specific question about Toolbox, then please go ahead, ask those questions now.
Oh, hey, something's gonna come back, I think. Oh, there it is, yay! Okay, anyway. So we get all that daily data, and we can actually do computations here now. So we can get an average using Excel format, Excel commands of just like the average of all the data.
And I must say, yeah, this is just getting the data way too quickly. You know, this is. I mean, you know, sometimes if you want to do this and start from scratch, just would take a very long time to get to something like this.
Yeah.
So it's the magic of Climate Toolbox. Yeah. So I just want to say that I hope, you know, we have the the presentation recorded. We share the slides. If you need more information, connect with me or Katherine, specifically if you want to talk about Climate Toolbox. And as Heather mentioned earlier, we are here really to provide help, and just if you have questions about climate and data, please reach out. And before you go, if you can just, I said in the chat, if you can provide us a quick feedback on the session, what would have helped, what worked for you, etc. And thank you again, everybody, for joining. And we hope to see you at some other sessions during this week.
Imtiaz, there was one question in the chat from Dory. Do you know if anything like this toolkit exists for coastal or marine systems? So
Katherine just answered it. I think Katherine, you want
she
to say
did. Oh,
something
did she?
more?
Okay.
Yeah, well, I don't know of any toolkit. The only thing I know for coastal and marine systems is there's a tool that you can explore sea level rise, but it's only with single metric. So it's not like a toolkit, right? It's an individual tool to explore a single variable.
But all the land areas along the coast are within the CONUS is covered under the Climate Toolbox, right?
Yeah, that is true. That is true.
So Climate Toolbox, as long as you're looking at a terrestrial system
Yes,
with a grid within CONUS,
Yeah.
you can use Climate Toolbox.
That is correct. I just don't know about, like, for coastal and marine systems, I think the kind of things that you're interested in is like sea level rise, acidity of the water, temperature of the water. So that would be like sea surface temperatures and yeah, so I don't know of anything that is a toolkit for exploring that kind of data.
Right. Yeah. Well, good luck, Dory. Well, thank you all very much again, and we hope to see you all soon in other sessions. And thanks so much, Katherine.
Okay, thank you.